Hi everyone, this is topic 4.5 Stoichiometry, and this is taken from AP Chemistry College Board. In this topic, I'll be talking about then what is stoichiometry and where do we actually need it in the calculations. Now, whenever we are talking about the stoichiometry, it's where the first thing is the balancing of chemical equations. Now, I have already told you that whenever we are talking about a chemical reaction, the left hand side of the arrow are the reactants and the right hand side of the arrow are the products. And there's always a law of conservation of mass which says that the mass can neither be created nor be destroyed. It remains same for the reactants and the products. Now you can see here that this is a balanced reaction. Why? Because on the left hand side and the right hand side the number of the atoms is exactly same. For example, if we are talking about sodium is 2 here and here also it's 2. So this is a balanced reaction for sodium. Then hydrogen, let's see, hydrogen is 2 multiplied by 2 is 4, and here also 2 plus 2 is 4. So in total the hydrogen atoms are also 4 on both the sides. And then oxygen, here there are 2 and here also there are 2 oxygen atoms. So this is a balanced chemical equation. This is the place where stoichiometry is important because it tells you that what coefficient should be there and how many moles of each reactant is reacting together to give the product. Another key concept is the mole. Now I have discussed this already in one of the topic, that what is a mole. Basically the mole is a unit of the measurement in chemistry that represents the amount of a substance. Now whenever we are talking about 1 mole is always equal to 6.02 multiplied by 10 to the power 23. Here we can see some examples where 1 mole of hydrogen atoms will be equal to 6.02 multiplied by 10 to the power 23 atoms of hydrogen. 1 mole of water molecule is equal to 6.02 multiplied by 10 to the power 23 molecules of water. So whatever is the thing, 1 mole will always be equal to this quantity, that is 6.02 multiplied by 10 to the power 23. And it depends that what we are taking in, is it atoms or molecules or ions or electrons, then we can say that these are the number of particles present. Now let's see that where these two concepts can be applied. So the question here is, how many moles of potassium metal is required to fully react with 11.6 moles of water? Now here in this question, we can see that there is a reaction happening between the potassium metal and the water. So the first thing is we need to write the reaction so that we can apply the law of conservation of mass. So we will write K plus H2O gives KOH plus H2. Now the next thing is balancing. After balancing, we get 2K plus 2H2O gives 2KOH plus H2. The next thing is, here you can see that the moles of potassium metal we need to calculate, and the moles of water is given. So basically we need to connect the moles of potassium metal with the moles of water. Now here, since the given value is already in moles, we just need to write the appropriate mole ratio. Now you can see the ratio between potassium and water, that is 2 moles of potassium, here you can see, is reacting with 2 moles of water. So we will write divided by 2 moles of water, and so we will write 11.6 moles of water here, and we'll multiply this with the ratio, and we will get 11.6 moles of potassium. So this is how we can apply the stoichiometry concept, first of all in balancing, and the next thing is to find the number of moles. And if you are asked about the quantity or number of atoms or the number of molecules, you can apply the same concept. First of all, you will find the number of moles and then connect it with the moles concept. From there you can find the mass, or you can also calculate the number of particles, that is, it might be atoms or molecules. If you liked the video, please subscribe to my channel and press the bell icon.